A intersection B is nothing but set of all the common elements in A and B, denoted as A intersection B. The symmetric difference between the two sets A and B is A delta B, that is nothing but A minus B union B minus A is called the symmetric difference. A union B is equal to B union A, or A intersection B is also equal to B intersection A. This is called the commutative law. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, Temple of Excellence. Today in this session I am going to take very important concept, that is operations on set. In my previous class we have discussed regarding the definition of sets as well as the construction of sets and the problems based on those construction of sets. Now in this session let us take the operations on sets. So usually the operations on sets we are going to study is union of sets, intersection of sets, then the complement of sets, A dash, B dash, and the difference A minus B, B minus A, and symmetric difference of sets. These are the things which we are going to study in this session. Now let us come to the first concept, the union of sets. Union, as you know, union means combination of all comes under a set, that is called union. If you combine all the elements of the set, then you will get an union of sets. That is, let A and B be any two sets, then the union of A and B is denoted as A union B, is defined to be the set of all those elements which are in A or in B. All the elements which are in A and B is denoted as A union B. All the elements which are in A or in B or in both is called the union of two sets, denoted as A union B. Now let us take for example, let A is equal to A, B, C and B is equal to C, D, E, F. Then the union of these two is A union B. Just write down first A, B, C. Then C is already written, D, E, F. So A, B, C, D, E, F is the union. So all the elements of A and B comes under the set that is called union of sets. Similarly, let us take one more example. If A is equal to 1, 2, 3, 4, 5 and B is equal to 1, 2, 3, 4, etc. up to 9, then the union of A and B is all the elements of A 1, 2, 3, 4, 5 including all the elements in B, that is 6, 7, 8, 9 up to 9 we will get. So union of A and B is 1, 2, 3, 4, 5, 6, 7 up to 9. Let us take one more example. If P is equal to 1, 2, 3 and Q is equal to, let us consider the elements like this A, B, C, then P union Q is nothing but all the elements of set A 1, 2, 3 and set B A, B, C. This is called the union of two sets. So that means in general, if A and B are any two sets, then the union of two sets A and B is all the elements X belongs to A or X belongs to B. All the elements in which A union B is nothing but the elements where X belongs to A and X belongs to B, X such that X belongs to A or X belongs to B. Now let us come to the properties. Suppose if A is any set, A union A, the union of the same set is same set itself. A union A is always equal to A. So the union of A and A is the same set we are going to get. A union A is equal to A. Suppose if this is the null set, if the union of a set and a null set is always equal to the same set, because in null set there is no element, union of a set and a null set is again a same set. So union of a set and a set is same set, A union A is A. Similarly, if you take the null union of a null set, A union null set is always equal to the same set. Similarly, the intersection, I will explain what is intersection. Intersection of a null set is again a null set, and if A is a subset of B, then A union B is equal to B. If A is a proper subset of B, then A union B is equal to B. Now let us come to the next concept, that is the intersection of sets. Intersection, let A and B any two elements of the set, then the intersection of A and B is denoted as A intersection B and is defined by set of all common elements between A and B. A intersection B is nothing but set of all the common elements in A and B, denoted as A intersection B. So A intersection B is nothing but the set X such that all the elements belongs to A and all the elements belongs to B. A intersection B is nothing but all the elements which are common to A and B. Now all the elements belongs to A and B. So let A and B any two sets, then the intersection of two sets A intersection B is defined to be set of all common elements between A and B. Now let us take an example. Let A is equal to A, B, C, D and B is equal to C, D, E, F, G, H. Then the intersection, the common in this is, so we don't have A, B, C is common in B and A and D is also common in B and A. So therefore A intersection B is equal to C and D. Similarly, let us take one more example. Let A is equal to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 and B is equal to 1, 2, 3 up to 9. The intersection of these two, A intersection B, is only the elements 1, 2, 3, 4, 5. That's all. That is equal to the set A. The intersection of A and B is equal to 1, 2, 3, 4, 5. That's equal to set A. Let us take one more example. If A is equal to 2, 4, 6, 8 and B is equal to another set 6, 8, 10, 12, then the intersection of these two sets is nothing but A intersection B is nothing but set of all common elements. What are the common elements? We don't have 2 here, 4 also not there, 6 is included in both the sets, 6 and 8 is also in set A and set B. So only 6 and 8 will comes under the intersection of the two sets. So union means the combination of all the elements, intersection means just nothing but the common elements in both the sets. Now let us come to the properties. Intersection of a same set, A intersection A is equal to the same set, because intersection of a set and a same set is equal to the same set itself. A intersection A is equal to A and intersection of a set and a null set is a null set. In null set means empty set, no elements are there. So intersection of a set and a null set is always equal to a null set. And similarly, intersection of a null set and a null set is again a null set, no element is present. So intersection of no element is nothing but no element, that is null set. If A is a subset of B, then A intersection B is equal to A itself. If A is the proper subset of A, if A is a proper subset of A, then intersection of A and B, A intersection B is equal to the same set A itself. Okay. Now let us come to the next, the difference between any two sets. The difference of two sets. Now difference is denoted as A minus B, A minus B, A difference B. So let us consider two sets. Let A and B be any two sets. Then the difference of A and B is denoted as A minus B is defined to be the set of all those elements which are in A but not in B. A minus B means all the elements which are in A but not in B is called the difference. Similarly, if B minus A means all the elements which are in B but not in A is called B minus A. So that is the difference A minus B is defined to be set of all those elements of A which are not in B. All the elements which are in A but not in B is called the difference. So A minus B means set of all the elements which are in A but not in B. Similarly, B minus A means set of all the elements which are in B but not in A, denoted as A minus B and B minus A. So it is also called as the complement of B with respect to A. Similarly, B minus A is defined to be set of all those elements of B which are not in A, and it is also called as the complement of A with respect to B. Right, complement of A with respect to B. Now let us take an example. If A is equal to A, B, C, D, B is equal to D, E, F, G, H, I, then the difference between these two, A minus B, elements which are in A but not in B, that is A minus B. A is included in A but not in here. So we can write A is in set A but not in B. Similarly, B is not in this, and C is also not in set B. Therefore, A minus B means elements which are in A are A, B, C, but they are not in D, A, B, C. Similarly, B minus A means the elements which are in B but not in A. So here we have this D is in both the sets, we cannot take D. E is not in set A. F is also not in set A. G is also not in set A. H is not in set. I is also not in set. So therefore the difference B minus A is equal to E, F, G, H, I. So all the elements which are in A but not in B is A, B, C. All the elements which are in B but not in A is E, F, G, H, I, that is B minus A. This is how we are going to find A minus B and B minus A. Now let me take one more example. If A is equal to 1, 2, 3, 4 Another example, b is equal to 4, 5, 6, 7. These are the two sets. Then how to find a minus b? A minus b means set of all those elements which are in a but not in b. In a we have 1 that is not in b. So similarly 2 is in a but not in b. 3 is also here. 4 is common, we don't want. So 1, 2, 3 is nothing but a minus b. The difference between a and b is 1, 2, 3. Similarly, the difference between b and a, b minus a means set of all those elements which are in b but not in a. So here 4 is there, 5 is not in a, 6 is also not in a, 7 is also not in a. So therefore 5, 6, 7 is nothing but b minus a. This is how we are going to find a minus b and b minus a. That is called the difference of two sets, denoted as a minus b and b minus a. Hope you followed, right? Now let us come to the next, symmetric differences. Symmetric difference. What is the symmetric difference means? Let us consider two sets. Let a and b be any two sets. Then the symmetric difference between a and b is defined to be a minus b union b minus a. The union of the difference a minus b union b minus a, and it is denoted as a delta b. The symmetric difference of a and b is a delta b is nothing but a minus b union b minus a. This is called the symmetric difference. So the symmetric difference between the two sets a and b is a delta b, that is nothing but a minus b union b minus a is called the symmetric difference. Now let us take a small example. So the union of the difference between the two, a minus b and b minus a union will give the symmetric difference. That's it. Let us consider a is equal to a, b, c, d, b is equal to d, e, f, g, h, I. Then a minus b, the elements which are in a are a minus b, a, b, c is a minus b. Similarly, b minus a means all the elements which are in b but not in a is e, f, g, h, I. Then the symmetric difference between these two is a delta b is equal to a minus b union b minus a. The union of these two. So the union of these two is a, b, c, e, f, g, h, I. A, b, c, e, f, g, h. This is the symmetric difference between a and b. That's it. Now let us take one more example. Let p is equal to 2, 4, 6, 8 and q is equal to 6, 8, 10, 12. Then to find the symmetric difference, to find the symmetric difference of this is p delta q is the symmetric difference. Now first find out p minus q. What is p minus q? All the elements which are in p but not in q. So we have 2 in p and 4 is also in p. 6, 8 is there, we don't want. So 2 and 4 is only the elements which are in p but not in q. Similarly, q minus p. All the elements which are in q but not in p. 6 is there, 8 is also there, we can take 10 and 12. 10, 12. 10, 12 are the elements. 6 and 8 is also included in A. Now, the symmetric difference between these two is P delta Q is equal to P minus Q union Q minus P. That's it. The union of these two, 2, 4, 2, 4, 10, 12. This is the union, that is the symmetric difference. So, the union of P minus Q and Q minus P will give the symmetric difference, that's equal to 2, 4, 10 and 12. So, if you observe carefully what we will get in these two examples, you might have been seen, except the common elements, all the elements comes under the symmetric difference, that's it, right. Now, let us come to the next concept, that is complement of a set with respect to universal set. Complement is denoted as A dash or AT. A dash or AT is called the complement of a set. So, let A be any set, then the complement of A with respect to U is set of all those elements which are not in A, that is U minus A, denoted as A dash or A complement. So, that is the set of all elements which are not in A, all the elements which are in U but not in A, that is nothing but U minus A. The complement of A is denoted as A dash or AC is equal to set of all elements which are in U but not in A, that is U minus A. This is called the complement. Suppose if you want to write the complement of a set B, if B is a set, then B dash is equal to U minus B. Now let us take an example. Let U is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8. is a set. Another set A is equal to 1, 2, 3, 4, and another set B is equal to 5, 6, 7, 8. These are the two sets. Now to write the complement of A, to find A dash and B dash, the complement of A and B is denoted as A dash and B dash. Now what is A dash? A dash is nothing but U minus A. U minus A. All the elements which are in U but not in A. 0 is here, that is not in A. So 1 is there, 2 is there, 3, 4 we cannot take, and remaining element 5, 6, 7, 8 comes under A dash. U minus A. All the elements which are in U but not in A. So in A we have 1, 2, 3, 4, 1, 2, 3, 4. Other than that 5, 6, 7, 8 and 0 is A dash. Similarly, complement of B is B dash is equal to U minus B. U minus B means all the elements which are in U but not in B. So that is 0, 1, 2, 3, 4, then 5, 6, 7, 8 is there, we cannot take. So here 1, 2, 3, 4 is nothing but complement of B denoted as B dash. So A dash is U minus A, B dash is equal to U minus B. All the elements which are in U but not in A is A dash. All the elements which are in U but not in B is called the B dash. So these are the elements, that's it. Hope you followed this. How to find the complement. Now let us come to the properties, algebra of sets. Let us know regarding some properties of sets. So commutative property, commutative law. If A and B are any two sets, then A union B is also equal to B union A, or A intersection B is also equal to B intersection A. That is commutative law. A union B is equal to B union A, or A intersection B is also equal to B intersection A. This is called the commutative law. So let us consider, for example, let A is equal to 1, 2, 3, B is equal to 2, 3, 4. Then find out A union B. A union B is nothing but all the elements 1, 2, 3, 4. And B union A. B union is nothing but same again 1, 2, 3, 4. So A union B is equal to B union A. Right. Similarly, find out the intersection. Intersection is nothing but the common element. A intersection B, the common in these two is 2, 3, 2, 3. And B intersection A is also 2, 3. So the intersection of A and B are same 2, 3. A intersection B is also equal to B intersection A. Okay. Now let us take one more example. If A is equal to 1, 3, 5, 7. Another example, B is equal to 7, 8, 9, 10. These are the two sets. Now the union, now let us verify to prove that A union B is also equal to B union A, first one, and second one is A intersection B is also equal to B intersection A. Now let us come to the first one, A union B. What is A union B? A union B is all the elements of A and B. 1, 3, 5, 7, 8, 9 and 10. Similarly, B union A. B union A is nothing but same 7, 8, 9, 10 and this. So we can write it on order 1, 3, 5, 7, 8, 9 and 10. So what do you say from these two? These two are equal. So therefore we can say A union B is also equal to B union A. So these are commutative. A union B is equal to B union A is the commutative property. Union. On the other hand, let us come to the intersection. A intersection B. What is the intersection B? The common in A and B. What is the common element? Only 7 is a common element. Similarly, B intersection A. The common element in B and A is also 7. So what do you say from these two? Therefore, you can say A intersection B is also equal to B intersection A. That is commute each other. So union A union B is also commutative. A intersection B is equal to B intersection is also commutative. A union B is equal to B union A, and A intersection B is also equal to B intersection A. Now let us come to one more property, that is called the associative property. If A, B, C are any three sets, if A, B, C are any three sets, then A union B union C is also equal to A union B union C. Just interchange this bracket, that's all. A union B union C is also equal to A union B union C. In case of intersection, A intersection B intersection C is also equal to A intersection B intersection C. This is called the associative property. That is, if A, B, C are any three sets, then A union B union C is also equal to A union B union C. This is first property. Or intersection of this A intersection B intersection C is also equal to A intersection B intersection C. These are called the associative properties. So, A intersection B intersection C is also equal to A intersection B intersection C. In case of union, A union B union C is A union B union C. Okay. Now, let us take an example. If A is equal to 1, 2, 3, 4, B is equal to 3, 4, 5, 6 and C is equal to 5, 6, 7, 8. Now, verify the associative law. Now, let us verify first one. First one is, what is the first law? A union B union C. What is to prove? A union B union C is equal to A union B union C. Now, let us find out first B union C. B union C. The union of B and C is, so B contains 3, 4, 5, 6 and 5, 6 is already there, 7, 8. So, now A union B union C. A union B union C. The elements of A and B union C. 1, 2, 3, 4. 1, 2, 3, 4 and again 3, 4 we have already taken, 5, 6, 7, 8. 5, 6, 7, 8. This is equation number 1. On the other hand, find out A union B first. A union B, union of A and B. A contains 1, 2, 3, 4. B already 3, 4 we have taken, 5, 6. Now, right hand side, what is right hand side? A union B union C. A union B union C. The union of this and C. First write down A union B, 1, 2, 3, 4, 5, 6 and C. The elements of C, 5, 6 is already there. We can take 7 and 8. See, this is equation number 2. What is say from equation number 1 and 2? From 1 and 2. Therefore, from 1 and 2, LHS is equal to RHS. Right. That means, therefore, A union B union C is equal to A union B union C. That's it. So, 1, 2, 3, 4, 5, 6, 7, 8. A union B union C is equal to A union B union C. That's it. Now, similarly, second one, intersection. Let us take this. Similarly, prove that A intersection B intersection C is equal to A intersection B intersection C. Now, let us find out first LHS B intersection C. So, B intersection C, the common elements in B and C is 3 is not there, 4 is not there, 5, 6. 5, 6 is the common element. Now, let us come to A intersection B intersection C. Now, A intersection B intersection C. So, the common in A and B intersection C. In here we have 1, 2, 3, 4, here 5, 6. 1, 2, 3, 4, here 5, 6, nothing is there. This is a null set. Null set. Okay. A intersection B intersection C is a null set. Similarly, come to the right hand side. A intersection B. The common in A and B. A contains 1, 2, 3, 4. Here 3, 4 is there. 3, 4 is the common element. We can write A intersection B is equal to 3, 4. Now, right hand side is A intersection B intersection C. The common in A intersection B and C. So, C contains 5, 6, 7, 8. A intersection B contains 3, 4. So, nothing is there. Therefore, again this is also a null set. So, both are null sets. So, this is a null set. Therefore, from 1 and 2 we can say that A intersection B intersection C is equal to A intersection B intersection C, which is a null set. They are equal. That's it. This is called the associative law in case of union of sets and intersection of sets. Very important. You may expect this type of questions for the point of examination. Now, let us come to the next property, distributive laws. So, if A, B, C are 3 sets, then A union B intersection C is also equal to A union B intersection A union C. See, if A, B, C are any 3 sets, then A union B intersection C is equal to A union B intersection A union C, and similarly A intersection B union C is equal to A intersection B union A intersection C. These are called as the distributive laws. Okay, A union and intersection. A union B intersection C is A union B intersection A union C. In case of intersection, A intersection B union C is equal to A intersection B union A intersection C. Right. Now, let us take an example on this. If A is equal to 1, 2, 3, 4, B is equal to 3, 4, 5, 6, C is equal to 4, 5, 6, 7, 8, verify the distributive laws. Let us verify first one. To prove that, I will take the first one. A union B intersection C. First law. A union B intersection C is equal to, what is the property? A union B intersection A union C. A union B intersection A union C. This is to be verified. Now let us take first B intersection C. B intersection C. The common in B and C is 3 is not there. 4, 5, 6. 4, 5, 6. So B contains 4, 5 and 6. That is also in the set C. So 4, 5, 6 are common in B and C. Now write down the union for this. A union B intersection C. The union for A and this. A contains 1, 2, 3, 4. And B intersection C already 4 is there. 5, 6. Let us represent this as equation number 1. Now come to the right hand side. On the right hand side, A union B first. A union B. What is A union B? A and B union 1, 2, 3, 4. In A we have 1, 2, 3, 4. B 3, 4, 5, 6. 3, 4 is already there. We can take 5, 6. Similarly, A union C. A union C. What is A union C? A union C. A union C is equal to 1, 2, 3, 4. 1, 2, 3, 4. And C. C contains already 4 is there. We can take 5, 6, 7, 8. Now, the intersection of these two, A union B intersection A union C. The intersection of these two. So, take the intersection. Intersection is nothing but the common element in this. Common is 1, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. 6 is also here. 7, 8 is not there. Let us represent this as equation number 2. See equation 1 and 2. What is here from 1 and 2? 1 contains 1, 2, 3, 4, 5, 6. 2 also contains 1, 2, 3, 4, 5, 6. Therefore, from 1 and 2, we can write LHS is equal to RHS. That is A union B intersection C is also equal to A union B intersection A union C. This is the first property. That is a distributive property. Now, similarly, let us take one more distributive property is there. So, what is that another distributive property? In case of intersection, let us take this. So, second property, A intersection B union C. Second one, A intersection B union C is also equal to A intersection B union A intersection C. This is the second distributive property. Now, let us find out A intersection B. First, write down B union C. B union C. Let me write all the elements of A, B and C. So, A contains 1, 2, 3, 4. B contains 3, 4, 5, 6. And C contains 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. Okay. Now, let us write B union C. B and union C is 3, 4, 5, 6, then 7, 8. Okay. Now, A intersection B union C. So, the intersection between these two. What are the common elements? Only 3 and 4. 3 and 4. See that the common elements are 3 and 4. Now, let us represent this as equation number 1. Now, find out A intersection B. What is A intersection B? The common in A and B. A intersection B common element is 3, 4. And similarly, A intersection C. A intersection C. The common element in A and C. The common element in these two, A and C, is, what is the common? We have only one element, that is 4. Okay. Now, write down the union for this. A intersection B union A intersection C. The common element A union B contains 3, 4, and A intersection B is also contains this. So this is equation number 2. What do you say from 1 and 2? So from 1 and 2 LHS is equal to RHS. Therefore from 1 and 2 we can say from 1 and 2 A intersection B union C is also equal to A intersection B union A intersection C. That's it. This is the second distributive law. Very, very important problem. You may expect this type of question for the point of examination. Just verify, that's it. You will get 3 marks for each property. Okay. Hope you followed. Now, let us come to the last property, that is De Morgan's law. So, what is De Morgan's law? If A and B are any two sets, then A union B whole dash is equal to A dash intersection B dash, and in case of intersection, A intersection B whole dash is equal to A dash union B dash. These are called as the De Morgan's law. So, that is, if A and B are any two sets, then A union B whole dash is equal to A dash intersection B dash, and A intersection B whole dash is equal to A dash union B dash. Now, let us take a small example on this. Now, what is given? If U is equal to 1, 2, 3, 4, 5, 6, 8 and 9, 7 is not there. A contains 1, 2, 3, 4, 5 and B contains 3, 4, 5, 6, 7. Verify De Morgan's law. Now, let us verify first De Morgan law. What is first one? A union B. So, to prove that A union B whole dash is equal to A dash intersection B dash. A dash intersection B dash is the first property. Now, first find out A union B. The union of A and B. A and B contains, A contains 1, 2, 3, 4, 5. B contains 6 and 7. This is A union B. Now, find out A union B whole dash. What is A union B? The complement of A union B is nothing but U minus A union B. The complement. All the elements which are in U but not in A union B. A union B whole dash is nothing but universal set minus this. So, universal set. What is universal set? Contains 1, 2, 3, 4, 5, 6, 8 and 9. Whereas A union B contains all the elements. Now, U, all the elements which are in U but not in A union B. So, 1 is there, 2, 3, 4, 5, 6, then 7. So, 8 and 9 are not in the first set. That is, 8 and 9 are not in A union B whole dash. That is, U minus A. 8 and 9 are in U but they are not in A union B. Now, come to A dash. A dash is nothing but U minus A. All the elements which are in U but not in A. So, in A we have 1, 2, 3, 4, 5. Other than this is 6, 8 and 9. A dash is 6, 8 and 9. Similarly, find out B dash. B dash. Complement of B is nothing but U minus B. All the elements which are in U but not in B. U minus B is called B dash. So, U minus B. So, B contains 3, 4, 5, 6, 7. 1 is there which is not in A, which is not in B. 2 is also not in B. 3 is there, 4 is there, 5, 6, 7, 8 and 9 are not there. 8, 9. Now, let us take the intersection of these two. Now, therefore, A dash intersection B dash. The common in these two. What is A dash? A dash we have 6, 8, 9. B dash 1, 2, 8, 9. What is the common element? 8, 9, 8, 9. 8, 9. This is equation number 2. See, what is the difference between 1 and 2? From 1 and 2, you can say they are equal. See, 8 and 9, 8 and 9 are right here. Therefore, from 1 and 2, we can say A union B whole dash is equal to A dash intersection B dash. That is first De Morgan's law. So, this is verified. So, A union B whole dash is 8, 9. A dash intersection B dash is also equal to 8, 9. So, therefore, A union B whole dash is equal to A dash intersection B dash. Now, let us come to the second property. That is, second one is A intersection B. So, to prove that A intersection B whole dash is equal to A dash union B dash. Okay. Now, let us come to this A intersection B first. A intersection B. A intersection B means all the elements which are in A and B common. So only 3, 4, 5 are the common elements. 3, 4, 5. 3, 4, 5. Okay. Let me write the values of A. A is equal to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And what is B contains? B contains 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. And what is U contains? U contains 1, 2, 3, 4, 5, 6, 8, 9. 1, 2, 3, 4, 5, 6, 7 is not there, 8 and 9. Okay. These are the elements given. Now, A intersection B, the common in A and B is 3, 4. 3, 4 are the common elements. Now, what is to find A intersection B whole dash? A intersection B whole dash is nothing but U minus A intersection B. All the elements which are in U but not in A intersection B. All the elements which are in U. 1 is there, 2 is there, 3, 4, 5 is included in B. So, 6, 8 and 9. All the elements which are in U but not in A intersection B is 1, 2, again 3, 4, 5 are there, leave that, 6, 8 and 9. Let us represent this as equation number 1. Now, second part, A dash. A dash is nothing but U minus A, all the elements which are in U but not in A. So, U minus all the elements which are in U but not in A. 1, 2, 3, 4, 5 is there except 6, 8 and 9. Okay. Now, similarly, B dash is U minus B. All the elements which are in U but not in B. So, elements which are in U but not in B is, so here 3, 4, 5, 6. 3, 4, 5, 6. We can write 1. 1 is in U but not in B. 1, 2, 3 is already there. 4, 5, 6, 8 and 9. Right, 8 and 9. Now, what is to find? A dash union B dash. Write down the union for these two. So, A contains 1, 2 and 6, 8, 9. See the difference between 1 and 2. What is 1 contains? 1, 2, 6, 8, 9. 2 also contains 1, 2, 6, 8, 9. What do you say from 1 and 2? LHS is equal to RHS. So, therefore, from 1 and 2, LHS is equal to RHS means, what is the conclusion? The De Morgan law, A intersection B whole dash. A intersection B whole dash is also equal to A dash union B dash. A dash union B dash. This is how we are going to solve the problems using De Morgan's law. Okay. So, this is regarding the De Morgan's law is concerned. Very simple and very, very important for the point of examination. That's all regarding today's session. Let us meet with different types of problems in the next session. Thank you. Thank you very much.